I'm gonna talk about global water problems. Basically, all the problems that are occurring right now that have anything to do with water on Earth. The first and obvious one, which I'm sure you would have been able to tell me if I was in class, is the fact that we're using water unsustainably, or better yet, we're over consuming the water that's on Earth. Even though water is supposed to be a natural cycle and it's supposed to replenish naturally, the way we use water is so we overuse water to the point where the rate of replenishment is affected. And here's just a chart of how much the US uses water in comparison to other countries. And as you can see, it's almost 3 times as much. Obviously, urbanization and misuse of water have contributed. The first thing I want you to know is that when we overuse water, obviously we're taking water from a lake, but it's always the fact that we're taking water out faster than it can replenish. So if we're depleting a lake, if rain doesn't fall over the lake, basically we have a critical water shortage. This can happen to groundwater as well. So we take water from the ground, and we're gonna remember we talked about the water table and how that measures the level of water. When we do this faster than it can replenish, we have 2 things that can happen. One is subsidence, which is basically sinkholes, and the other one is saltwater intrusion, which is saltwater entering fresh. So if you see here, here's the water table at its highest. This is a point of the water table being at its lowest, and the saltwater can actually flow this way instead of the normal runoff, which occurs this way. This is an example of a sinkhole, and I put this picture here because this happened in Florida, and Florida is known for undergoing a lot of these problems. And this is a place near Orlando, or near, let's say, Walt Disney, that went through a sinkhole because, I mean, they can't really pinpoint why, but it's because of the water table being low. Another big problem is the distribution of water. Sadly, there's areas that obtain more water than others, and I want you to think of this. We know there's countries that have no water at all, okay? But this problem occurs within states. We have states within the United States of America who are suffering from water. And then the problem can even go in terms of cities. Some cities have high levels of water while others do not. And then you're going to see problems just within farmers not being able to obtain water. Droughts obviously leads to lack of water. And anytime you have a period where there's going to be very little precipitation, or evaporation is going to be faster than the rate of precipitation, you're going to have a period of drought. And some things that are going to result from drought is dry soil, shifts in biomes. These are things that we've already talked about that can occur. Reducing water flow in general. So if you have drought, the water flow stops, and decreasing of trees growing and crops growing, because without water, trees and crops can't grow. And this is a quote from your book, that droughts have tripled on Earth in between these years, which you know how many things have been going on. Another problem with water is pollution. And to remind you that even though you can't use this word on the test, you want to know that it means any introduction of chemicals, physical or biological agents that are going to degrade the water. And by that, you mean take the water to a state which can no longer be used. As we learned before, there's 2 types of, or 2 main sources of pollution. One is direct, which we call point, and it's traceable and comes from a single source. So if you go back to that test question, the single source is kind of a key word that defines this, but traceable is really the key. So anytime you see a type of pollution that you can't trace back, you're going to choose non-point, which I'm going to talk about in a minute. This is an example of sewage, and the reason sewage is point is because the sewage dumps their water directly into a large body of water, so that you know it's, I mean, this is a sewage plant, so it's point. Non-point is indirect, and it's mainly caused by runoff. And here's all these examples of runoff. Runoff from industry, runoff from agriculture, runoff from the streets. I want you to keep in mind that anything that happens on land is going to run off into our body of water. So everything that happens in land will either run off into a large body of water through surface runoff, or it can leach or seep into aquifers, which is our groundwater, which at the end, this is a picture of an aquifer, and you know where they're heading out to the river, is an underground river, so that'll end up in surface water as well. So everything you do on land ends up in our water supply some way. Underground water is going to have little or slow decomposition. It's going to have less dissolved oxygen, and it's going to have less flow. So there's going to be less chance for pollution. So any groundwater pollution that reaches the surface is going to be highly concentrated because of these things. So let's talk about these types of water pollutants, because there's several categories you have to become familiar with. The first ones are pathogens. Pathogens are any bacteria or virus or any harmful organism that can affect the health of another organism found in the water. Another group is organic matter, which is going to be waste or remains from both animals and plants. That's what we call organic matter. Organic chemicals or compounds in general are going to be compounds that have at least 2 carbons. And remember, even though we're not talking about water pollution here, remember that methane is an exception. It's considered an organic compound. But organic compounds that you might not even consider are pollutants, one of them is plastic. Plastic comes from fossil fuels, or is derived from fossil fuels. And fossil fuels are obviously living things, and all living things are composed of carbon. Organic fertilizers and pesticides are going to contain are going to be considered organic chemicals because they contain organic compounds. And then obviously fossil fuels in general are considered organic chemicals. I want you to know that all of these things I just talked about, pathogens, organic matter, and any organic chemical, in order to break down that waste or that pollutant or that chemical compound, you're going to need oxygen-demanding bacteria. And what that means is any of that waste that's in the water that shouldn't be is going to require a type of bacteria that uses up all the, well, not all, but a lot of oxygen in the body of water in order to break down the waste. So I want you to look at this chart, okay? Here's a normal or clean zone of water. The dissolved oxygen levels are high, and oxygen demanding bacteria are low, or they call this biological oxygen, okay? As the bacteria gets high, which is a result of either dying fish or dying plant matter, you're going to have oxygen demanding bacteria high, which starts to drop the levels of oxygen. And in here they call this like the septic zone, because it's the lowest levels of dissolved oxygen because there's so much decomposition going on. Eventually, once the waste is completely decomposed, oxygen levels will rise, and then you'll see the drop of the decomposing organisms. Another group is inorganic chemicals, and these are going to be anything that obviously doesn't have 2 carbons. We've got acids, bases, and salts. And I know you think of those as normal occurrences, but when a body of water is highly acidic, like due to acid decomposition or acid precipitation, then you consider that like pollution, right? If the water is too basic or highly concentrated in salt, like a fresh water, if you see here, you've got snow melting, and in the snow, there's always some levels of salt, and they can melt into a body of water. Then you end up with salt water or salt in a freshwater body. Heavy metals like lead, copper, arsenic, cadmium, and mercury. I just want you to know that heavy metals obviously are a big problem in our water. You don't have to know all of these metals. We're going to learn about them when we do toxic chemicals and compounds. I just want you to be familiar with the fact that they existed in our water, and it led to a lot of laws to prevent these from seeping or leaching into our water. And in addition, the need for treatment of water, which is what I'm going to talk about in a minute. The last two are physical and sediments. So physical agents is going to be anything that has to do with heat or thermal pollution, and we'll talk about that a little bit later. And sediments, obviously, particles of soil or silt, which are showing here, easily runoff from agricultural lands or erosion or land degradation.